Hello everyone, this is the third video in the SolarGators electrical integration series. Today we're going to be going over the power section of the board, so it's going to be a relatively short video. The power section, so right now I have open the completed integration board, so what you guys will be designing and editing a little bit. The power section contains a few main parts. The first one is this part over here, the connector. It's just a normal 2-pin male header. These three parts over here make up a pi filter. So there's one 0805 farad bead and two 0402 capacitors. The main piece right here is the linear regulator. And then these two parts are a resistor and an LED, just to provide a little status for when the power is on or off. So let's go ahead and take a look at the schematic for the power section. So everything in the power section is up here. Like I said, the connector you have here, the pi filter, the farad beads, the two capacitors, the linear regulator, the one capacitor, and a bulk decoupling capacitor. I didn't mention that before, and our two our diode and our resistor. We have a couple flags here, 1 and 2 ground flags, a voltage bus flag, so for whatever the voltage bus coming into the device is, and a 3.3 volts flag for the output of our linear regulator. Okay, so let's go ahead and start designing this. Okay, so like I said, the first part that we're going to need is that that connector. I never remember what the part number is for this connector, so I'm going to go ahead and copy the description. You guys don't need to do this. I'll tell you what the part number is in a moment. But as I said, we're just going to get this from the manufacturer part search. I'm just going to grab this third one, place it down, and as you can see, the part number for if you want to grab the same part is TSW 10207LS. If you want to pause the video and copy that into your manufacturer part search, go ahead and do that. For now, I'm going to rename this to power. And we're going to start placing some more components. So for most of the rest of the components, we're going to go ahead and use generic components from the Phil's Lab library. So I'm going to go to components. All seems being a little glitchy. I do not have libraries loaded into this project. We did cover loading libraries into the project in the first video, but I'm going to go ahead and add them now. I have a lot of versions of this project. Okay, so I'm going to go ahead and, like I said, grab some parts. So components, Phil's Lab, and I'm going to do a ferrite bead. So we're going to grab an 0805 ferrite bead and hit place. And like I said, to stop placing something, you go ahead and hit escape. And we're going to get some capacitors. We're going to use 16 volt 0402 capacitors. Like I said, we'll probably end up powering this on 5 volts, but we use 16 volt capacitors so because of what's called a DC bias. So whenever you're putting a DC voltage across the capacitor, you always want to choose a capacitor value that is much greater than whatever that DC voltage is going to be. Okay, so now to select our part values, I'm just going to go ahead and tell you this will be C1, this will be C2, and for the capacitors, we're going to be using 2.2 microfarad capacitors, 2.2 microfarad capacitors. And now for the ferrite bead, JLC doesn't carry a lot of ferrite beads in their basic parts category, so we're going to go to JLC in order to choose what value ferrite bead we're going to use. So I'm going to go to JLC PCB parts. I'm going to look up ferrite, or we're going to go to basic preferred extended parts, go to ferrite. Okay, and we have 3 ferrite beads available to us. I'm going to go with this one. It is 0805 and with a nominal value of 100 ohms at 100 megahertz. So I'm going to go ahead and choose 100R for 100 ohms. Oops. My screens are a little messed up. And we're going to start running some wires. So to start a wire in Altium, you hit Control W, and we're going to click here, and it's automatically going to create this little connection point here. We're going to finish this part over here. Altium will give you this red warning line if you have 2 components which have the same designator. So I'm going to go ahead and change that to C2 or same value. Okay, now we're going to do the ground side. So this is going to be ground, and we'll connect it up over here and use the ground flag. Okay, so there's our connector. Oh, let's make that J1. In order to change these values, I'm double clicking on them and changing the value. Okay, let's go ahead and grab the linear regulator. So I'm going to go to panels, components, and I believe it is the AMS. Oh, no, you'll probably find it by looking up 1117. No? 3.3. Okay, doesn't look like he has it in his library, so we're going to find it in manufacturer part search. Panels, manufacturer part search. And we're going to do 11117 dash 3.3. Let's see if it comes up. Yeah, we'll go ahead and use this one for Texas Instruments. Like I said, yeah. Oh, actually, I don't like the, yeah, we'll go ahead and use this one. Okay. So our input is going to be just from here to here. We're going to name this 1. U is usually the designator for integrated circuits. The output is going to be, like I said, our 3.3 volts. And I'm going to place the VBus and 3.3 volts flags now. So you can right click on the power port menu up here and place I'm just going to do a 5 volts power port, 1, 2, and we're going to edit it by double clicking on it and doing 3.3 volts. Oh, and I never said that I want it to be showing. And I'm going to make this one, oh, no, sorry, I made a bit of a mistake. This one is going to be 3.3 volts showing. This one is going to be the bus for voltage bus. Okay, now we're going to do our resistor and LED to show that power is actually coming through. So like I said, we're going to go to components, Phil's lab. I'm going to look up LED. I'm going to be using an 0603 red LED just because 0603 LEDs are the most common one on JLC PCB's parts menu, basic parts. Make this D1 for diode 1. I apologize if I'm going a little fast, but you can always pause the video. I'm going to go to components again and get a resistor, RES, another 0402 component, place. Now, for those of you who don't know about diodes or LEDs, This paddle or this vertical line should always be facing the side of lower potential, or the negative or the ground side, and this side will be our 3.3 volt side. It doesn't matter which side you put the resistor on. I'm going to just put it here and go with R1. And we're going to do a 1 kilo ohm resistor. If you would like, I guess I'll explain why we choose 1 kilo ohm. Essentially, we choose 1 kilo ohm because most of these sort of LEDs want a specific amperage going through them. Most of them are around 25 milliwatts, and we have 3.3 volts going across them. And so if you add 1 kilo ohm to the few ohms that are going to be across that are going to, the few ohms of resistance that an LED would represent, 3.3 divided by 1K is going to give you around 3.3 millivolts. So, 3.3, milliamps, which is well below the maximum that you can have on an LED. So, yeah, that's why we use a series resistor. But now that I think about it, that 1 kilo ohm seems sort of high, so we might change that later. But for now, it's fine. So I'm going to go ahead and right click again and place a ground power port. Control W, move that over there, and again run this side to ground. So there we go. There is our power section of our board. So I'm going to go ahead and save that, and that's it for the video. Thank you.